Okay, so let's start with today's discussion. Today's topic that I am going to discuss is the name is dynamic memory allocation. It is one of the very important and interesting topic in C programming language, which has a huge number of applications in your upcoming semester subjects like data structure, where you are going to implement linked lists with the help of this kind of dynamic memory allocation technique. Okay, because each and every node in the linked list will be created with the help of this dynamic memory allocation. So wherever you are going to apply the linked list data structure, you are going to apply the linked list data structure to implement stack and queue. You are going to apply the linked list data structure to implement trees, various kind of tree and or graph data structure. Okay, so linked list data structure is working like a very important and best kind of data structure, which actually use the concept of dynamic memory allocation or dynamic data structure compared to your static data structure like array. Okay. So in last class, I already discussed some of the very basic concept of dynamic memory allocation. So just give me some time to make a what are the device of that theoretical concept of dynamic memory allocation, and then we are moving into our programmatical point of view. Okay. So as the name suggests, the memory allocation will be done dynamically in the computer system. That's why it's called dynamic memory allocation. So we have to follow such kind of methods by the help of which we are able to allocate the memory to a certain data structure. We are able to allocate the memory in a dynamic form instead of static form. So the difference between dynamic memory allocation and static memory allocation, there are lots of several differences are there, but we are mainly focused on the advantage of using dynamic memory allocation over static memory allocation. So in the last class, I just discussed a very basic advantage, that what is the advantage of the data structure like linked list, where dynamic memory allocation is using instead of the data structure like array, where static memory allocation is using. So you have already seen that while we declare an array, we have to pre-specify the size of the array, a certain size of the array. Like if we declare an integer array, suppose int a, then within third bracket, we have given the size of the array as 20 or 30 like this. Okay, so that size is actually making fixed during the compile time of the code. That means while you are writing the code, you have initialized the predefined size of the array. That means the static allocation of memory block from the computer system, which will occupy that 20 bytes, not 20 bytes. It is an integer array, so each integer will take 2 bytes. It's based on the architecture of your system. So 20 into 2 means total 40 bytes memory allocation has been occupied by the help of that particular integer array A, right? But while during the execution of your program, while you are giving the input inside that particular array, into that particular array, suppose you are going to give an input of 10 integers instead of 20 integers. But you have predefined the size of the array as 20 integers or the 20 integers. So if you declare 10 integers, then the rest of the 10 integer size, that means 20 byte size, if each integer size is 2 bytes, then the rest of the 10 integer size will be wasted, totally wastage, and that wastage will create several loopholes in terms of space complexity or space occupancy in case of array static allocation, right? So this kind of problem can be overcome or can be handled efficiently by the help of this dynamic memory allocation strategy, where you can demand the memory while you are executing your program. So it will actually increase the scalability of occupying the memory in your computer system. So not only increase, you can also decrease the size of the memory, right? So in case of static memory allocation, it is also a problem. Suppose you have defined a 10 byte size initially for a predefined size of a static allocation of an array. And suppose while you are executing your program and you are giving the input into that particular array, you are giving 11 elements. Okay, you have to give 11 elements as per the new requirement of the customer. So the problem is that you have given the predefined size of the array is 10, but you have to give the input as 11 units or 11 integers. So one integer size will be required more. So that is the problem. So you have to again re-enter the algorithm, re-enter your code. You have to again redefine the size of the array, and then you have to again rerun your algorithm, and then give the extra size of that extra element as per the demand of the customer, right? So not only this is a problem while you are going to give a less amount of size, but also the static memory allocation is a problem while you are going to give a bigger amount of size. Okay, so scalability, the overall the scalability, that means the computer memory size scalability is an issue in case of static memory allocation, and that issue will be efficiently solved by dynamic memory allocation. So you can easily efficiently increase or decrease the size during the runtime or during the execution time of your program as per the demand of the customer. Okay, so that is the overall concept or benefits of dynamic memory allocation over static memory allocation. So linked list is such kind of data structure which follows the concept of dynamic memory allocation, and array is such kind of data structure which is generally follow the concept of static memory allocation or fixed memory allocation. Right. So so in this slide, it has been written that many a time we face situation where the data are dynamic in nature. Actually, the real life data are generally dynamic in nature, mostly dynamic in nature. Because real life data like the stock market data or weather forecasting data, these are the most of the kind of real life data, Facebook data or Twitter data, whose volume is increasing in the time by time. Okay, you cannot predefine the size of the memory for handling such kind of big data. Okay, so in this case of things, in this case of situation, you will have to use the concept of dynamic memory allocation instead of static memory allocation. Otherwise, the static memory data structure will completely fail in case of handling such big data type of real life applications. Okay. So obviously you can understand how dynamic memory allocation is important over array. Okay, in a certain application. So such situation can be handled more easily and effectively using dynamic memory management techniques. Okay, the situation which I have already discussed. Now, what is dynamic memory allocation? It is a memory space required can be specified at the time of execution, which I have told that you can give the memory space according to the choice of the user or according to the requirement of the customer at the execution time of your program. Okay, so you don't need to predefine the size of the memory space in case of dynamic memory allocation, unlike static memory allocation. Right? So C supports this kind of allocation, and not only allocation, it will also support the freeing of allocated memory. Freeing means deallocation of the memory. So whatever memory have been allocated, if that memory will not be used longer for a certain amount of time, then you will require to deallocate that memory or deoccupy the memory. Because if you are not going to deallocate that particular memory, which will be held by some previous data structure, which are not currently used for a longer period of time, then that memory cannot be used by some other data structure in future. So that memory is actually wasted. So that's why the freeing of memory dynamically, or you can say the deallocation of memory dynamically, is also very important job in case of C programming language. So C programming language not only allocates dynamically the memory, but also freeing or deallocating the memory dynamically. So there are different kind of system defined function or library routines are there, which are used like a to do the job of allocation and deallocation. And all kinds of dynamic memory, one thing you have to remember that all kinds of dynamic memory will be allocated from a specific area of your computer system memory, and that area is called heap. The area is called heap. So from the heap, the memory will be allocated. The heap is actually nothing but a pool of memory, and from the heap, the memory will be allocated a specified amount of memory as per your request, or requested amount of memory will be allocated in your program, okay, to store the data. And while you are applying the free or deallocation of the memory, that, that deallocated memory is again returned back to that particular heap from where it has been allocated. Okay, so every time you are going to your program is going to access the heap memory portion of your computer system, and heap is a portion of your main memory. Please remember it. Heap is a portion which actually resides in your main memory, that is RAM. Okay. So these are the four functions that you have to give a concentration. That these are the four functions are majorly are playing a vital role to perform this kind of memory allocation and deallocation dynamically. Okay. So the first two functions is mainly responsible for the allocation of new memory dynamically as per the requested request of the user or the customer. So malloc function is there and calloc function is there. So malloc function allocates requested number of bytes. Bytes means memory. You can say if it is integer, then 2 bytes. If the character, then 1 byte. If it is a float, then 4 bytes and so on. So malloc function allocates requested number of bytes or memory and returns a pointer to the first byte of allocated space. Returns a pointer to the first byte of allocated space. So all of you have to remember this malloc function is such kind of function which will actually allocate requested number of bytes dynamically into your computer system memory and returns a pointer to the first byte of the allocated space. So if we are going to access the next byte of the allocated space that has been given with the access of the malloc function, then you have to do the pointer increment function, PTR plus plus. We have already done this kind of handling of memory blocks or the array with the help of pointers, which will point to the first byte of the allocated space. Right. In the same way, calloc is also used. Calloc function is also used to allocate spaces. Okay, in terms of bytes for an array of elements. This is very important, for an array of elements, right? So the major thing is telling like that malloc function is mainly used to create a single block of memory dynamically and returns a pointer to the first byte of that allocated memory space. Malloc is mainly used to create a single block of memory of allocated of the requested memory, single block of requested memory dynamically, whereas calloc is mainly responsible to create multiple blocks of requested memory. Very important. Malloc is mainly responsible to create single block of requested memory dynamically. Calloc is responsible to create multiple blocks of requested memory dynamically. There is the major difference between calloc and malloc besides the syntactical difference. Okay. And both malloc and calloc will return the pointer which points to the first byte of this allocated memory space. Please remember, both the function malloc and calloc will return the pointers which will point to the first byte of the allocated memory space. There is another major difference, another one important difference in malloc and calloc, that malloc after creating the requested memory or after creating memory as per the request, it will actually initialize the memory. Actually, it does not initialize any memory thing. Okay, it by default initialization happen, and that by default is actually store the garbage value. It will store the garbage value. So it does not do any kind of memory initialization in case of malloc function. But calloc function, when the calloc function is created, a memory dynamically, a block of memory, multiple blocks of memory dynamically, it will initialize those blocks of memory. Suppose you are not initializing that memory, so it will by default initialize the memory as 0. It by default initializes the memory to 0. That is important. But malloc function does not initialize the memory. So that's why by default it will take the garbage value as an initialization. Okay. These are third, you can see the major difference, one of the major difference between calloc and malloc. Okay. Sometimes the differences are coming into the exam or the interviewer will ask this question very frequently: what is the difference between calloc and malloc, and which method is suitable or which method is more advantageous according to you. Another difference I need to tell you, please remember that malloc function is faster than calloc function. Malloc function is faster than calloc function. So, okay, so apart from the syntactical difference, okay, syntactical difference I will show when I will deal with the program. Apart from the syntactical difference, there are three logical difference. The first logical difference, malloc function create one block of memory dynamically as per the request at a time, Whereas Calloc function will create multiple blocks of memory as per the request dynamically. Second difference, Malloc function initialize the created memory will be does not initialize the created memory, so it will be considered by default initialized with the garbage value, whereas Calloc function initialize the memory to 0. By default, initialize the memory to 0. Third logical difference, that Malloc function is faster than Calloc function in terms of processing speed as well as, so the vice versa. That means the Calloc function is slower than the Malloc function. Okay. So in some certain cases, Malloc has some advantages. In some certain cases, Calloc has some advantages. But Malloc is more preferable to use. Okay, more widely popular to use because of this speed. Okay, the faster Malloc function is faster, and it is easier to handle. And that means in terms of code complexity, okay, Malloc function is much easier than the Calloc function. That I will show you. Okay, Malloc function uses only one argument or one parameter you have to pass with the Malloc through the Malloc function, whereas two arguments will be passed through the Calloc function. We have to pass two arguments, at least two arguments through the Calloc function. Okay. So obviously, number of arguments will be increased. That's why the Calloc function is slower, and number of arguments will be decreased in Malloc. That's why the Malloc function is faster than Calloc function. Okay. So Malloc and Calloc. Then free function. What is the free function? Free function is a very common function which will be used as an ending statement before return 0, which will be used as an ending statement before return 0 with any one of these functions, Malloc, Calloc, realloc. All these three functions, it will be a common function, free function. Why? Because whatever memory you are going to create it may be a single block of memory or it may be a multiple block of memory. It may be by using Calloc or it may be maybe by using Malloc. Whatever your choice, you have to make it free before leaving the program. Otherwise, that program will occupy the memory and which will not be given to some other program. Okay. So freeing of the memory or reallocation of the memory is also very important job in case of C programming. In last class, I told that in case of Java programming or in case of Python programming, the Java, Python, object-oriented programming, in case of these two kinds of programming languages, the free function has no use because by default, Java will do automatic garbage collection. Like Python is also doing the similar job, automatic garbage collection. Automatic deallocation of the memory has been done within Java and Python. But C does not do any kind of automatic garbage collection or automatic memory deallocation. You have to do it explicitly through your program. Okay, please remember it. And the last function is the realloc. Realloc function has not a big use. Sometimes we may use it. Suppose if you want to modify the size of the previous allocated space. Suppose you have given the size of the Malloc, suppose 20 bytes. Now you have to resize that previously allocated memory space. Suppose you want to increase the size of the previously allocated memory space, you can do it with the help of realloc. Okay, reallocation. Realloc means reallocation. Okay, realloc means reallocation. Now the malloc, which I already told, so a block of memory can be allocated using the function malloc. I have already told a block of memory. Very important. Only one block of memory or a single block of memory will be allocated with the help of malloc function. All this function is a part of stdlib.h header file. All this malloc, calloc, free, realloc, this dynamic memory allocation function will be a part of stdlib.h header file. Sorry, stdlib.h header file. Right. So malloc function reserves a block of memory of specified size and return a pointer type void. This is very important to understand in terms of coding. That malloc function is always return a void pointer type by default. It will return a void pointer type by default. So if you want to store into an integer pointer type, you have to do it a type casting within your program from void pointer type to integer pointer type. How we can do it? That we are going to discuss. So the return pointer can be type casted to any pointer type. Here, and this is a general form of how we can do the type casting. So this is actually a pointer type casting. Okay, and this is the malloc function, and this is the byte size which you are going to specify. Okay, which you are going to specify, and that can be increased or decreased at the execution time of your program. Okay, that we will check. That we will definitely check. So this is an example. So p equal to the p is an integer pointer. Suppose we have declared the p as int star p. Now malloc will create a 100 bytes, 100 into size of int. That means it will create 100 integers, 100 elements. Each and every element will have a size of integer. So if in your system the size of integer is 2 bytes, so here it will occupy 2 into 100, that is 200 bytes. If your system architecture will give the size of integer as 4 bytes, so it will occupy 4 into 100, that means 400 bytes. Okay, and the first byte will be pointed by an integer pointer, that is p. Here, because it has been already written, I have already told. So malloc always returns the a pointer to the first byte of the allocated space. So this is the allocated space. So it returns the pointer to the first byte of the allocated space. So memory space equivalent to 100 times the size of the int. Now the thing is that now we can say that if we define the malloc function in such a way, then how we can change the size? Okay, obviously while you are interested to change the size at the runtime of your program or execution time of your program, then instead of 100 you will have to use a general variable here like n, and that n you are going to take as a runtime. Okay, at the runtime input, that means through the scanf you are going to take the n, so n into size of int, right? So that n, whatever value of n you are going to provide at the time of execution of your program, that amount of memory space only will be created in your computer system. Okay, so at the time of execution of your program, only we are going to decide that how much memory space you want as per the request of the customer. So customer can change it, and the requested amount of memory space, the first byte of the requested amount of memory space will be pointed to the integer p, which will be assigned here as the integer pointer of the malloc size. Okay, I think it is clear to everyone. So let's run one small program for you. This is a malloc program, a very simple program. stdlib.h header file I have defined here, and I have defined an integer pointer start ptr. Okay, so I am taking that n size. Look this two line very carefully. So I am taking the size of the n. That means this n into size of int. I am doing here n into size of int. That means this n is actually you are giving the value of n at the runtime or execution time of your program, and that amount of memory space only created in your system dynamically, or that amount of memory space will be allocated in your system dynamically during the execution time of your program. But in case of array, here you have to define the size of the array, predefine the size of the array, which may be wasted at the runtime of your program. Okay, because at the runtime of your program, you may change your mind. So you can take less number of size within the size of the array, or you can take more number of elements over the size of the array. So in both the cases, it will be a issues or it will be a problem. That problem can be handled successfully here with the help of dynamic memory allocation with malloc, right? So n into size of int. So everyone, please look at this argument very carefully. There is only one argument is passing. Please don't make it confused. There is no comma in between this n and size of int. So only one argument is passing. It should be a multiply. It should be a star. That means only one argument n into size of int will be passing as a argument of the malloc function. And it by default it will return a void pointer type. That's why a type casting to an integer pointer type is required, which will be stored into integer pointer type, or which will be assigned by the help of integer pointer type ptr. Now, if the ptr returns null, listen very carefully. If the ptr returns null, that means there is no enough space or sufficient space as per your requested memory is available in your computer system. What I am saying, if the ptr returns null, that means no space is available or no sufficient space is available as per your request. So in that case, you will have to handle this intelligently, this situation, and you have to print a statement, and then you have to give that exit function to terminate from the entire program. You have to use this exit function to terminate from the entire program if this situation happens. Okay, because if this situation happens, we have nothing to do. If your computer system does not, if you cannot provide you a LAN space or sufficient space to create the memory as per your request, then we cannot do anything. Okay. Now in the second case, so if this situation will not happen, then this situation will execute. So in this situation, what I have used, I am simply reading an array with the help of this PTR. PTR is a dynamic, is the first byte of the array. I have already told to access the upcoming byte or next byte of the array, we will do PTR plus plus. So this is actually doing PTR plus plus, PTR plus I. This form is already, you are familiar with this form. I have already used this form multiple times in previous program. Okay. So PTR plus I. Okay. So we simply did the reading of the n number of elements, the size that you have provided, and then we will do the printing of the elements. Simple reading and printing the values. So that's why I'm using the dereferencing pointer because I want to print the values of the array. Right. Simply run this program. So it will first enter a number of elements. Here you can decide that how many elements you want to enter. So this is the execution time of the program. You may give 5, or you may give 9, or you may give 7. So if you are giving 5, that means it will occupy the 5 memory space at the back end of your computer system, or it will allocate the 5 memory space at the back end of your computer system. So it will, there is no question of wasting any memory space which you have predefined in case of array. Okay, that is the major difference between array and dynamic memory allocation. Static memory allocation and dynamic memory allocation. So if you are giving 5, so after entering, that means 5 memory space has been occupied at your computer system memory, and the first byte of that 5 memory space will be pointed by the help of this PTR pointer, which will be assigned inside of your program. Right? Now it will simply demand the array as per the as per this code. It will demand the elements of the array. So I'm giving the elements 1, 2, 3, 4, 5. Okay, and it will simply print the elements of the array. So we can make this program little bit complex. That means we are doing the summation of the elements of the array. And it's very little bit complex. So that's why we have declared some variable which we have initialized as 0, and did activate this line sum equal to sum plus start PTR plus I. I think all of you understand why I am using start PTR, because I have to dereferencing the pointer type, which is increment operations, because all the values of that pointer type address will be added with the sum variable. We want the values, we don't want the address. So that's why we will do this dereferencing of pointer. Okay, if we want the address summation, then we will do only PTR plus I. We are not using this asterisk sign. So we want the summation of the values, not addresses. So that's why we will do PTR plus start PTR plus I. And here we will print the sum after getting the value. You can print that the elements of the array as well, your choice, or you can directly print the sum. I'm giving a new line and print the sum. Again, I am providing 5 elements, or suppose I am providing 7 elements. 1, 2, 3, 4, 5, 6, 7. So these are your elements of your array, and this will provide the sum of all the elements of your array. Is it clear to everyone? Tell me. Anyone has any doubt?
Yes, sir.
Is it clear to
Again,
everyone?
sir, can you
Yes.
again can you explain that garbage point in Malloc?
Garbage means the free PTR I have done here, which will deallocate the memory. The space, the 5 byte space we have allocated through this malloc function. At the time of execution, I have given 5. That means the 5 byte space has been already allocated and occupied with the value of this scanf function that we have given. Right. Now, if we want to deallocate that space, that means you want that you don't want to occupy the space. Now you want to close down your system. That means you don't want to run this program anymore, or you don't want to use that particular memory blocks anymore. You want to deallocate and return back that memory block to the heap section of the memory, because from where it has been allocated, that is a computer heap, computer memory heap. It's a part of the main memory. So deallocation will be performed, and the allocated memory will be deallocated and returned back to the same computer memory heap. And this deallocation can be performed explicitly with the help of this free function. So simply you will have to apply the free function, and within the free function you have to pass the parameter that is nothing but a pointer type PTR, which will hold the starting address of the memory. Okay, so this is called a deallocation. or garbage collector. Okay, but one thing is there, it is not an automatic garbage collector, it is an explicit garbage collector. That means you are explicitly write a command to collect the garbage of the memory. But Java, Python, you don't require to write this command. Okay, because there is an implicit garbage collector exists in Java. That means automatic garbage collector exists in Java. So if you are switch off this program, okay, then the CPU will check that how much time you are not using that particular block of memory which you have occupied. So after that time will be over that particular threshold value that the CPU is waiting for, then the CPU is automatically garbage collected or deallocated the memory which you have occupied. Okay. This is a malloc function. Similar way, you can do the calloc function. Only the difference, the rest of the codes are very similar. Only difference is the definition of the calloc. In this line, the difference stays there. Rest of the code are very similar, very similar with malloc. So here, if you see within the calloc function, two arguments are passing. One is n, and the one is size of n, size of int. That means two arguments are passing separated by comma. And in malloc function, only one argument is passing. Okay, multiply means only one argument, not separated by comma. And in calloc function, two arguments is passing. That's why calloc is slower than the malloc in terms of argument passing or calling or some other cases. Okay, so you have to use calloc, the name calloc instead of malloc. This malloc calloc is also part of that among those 32 keywords in C. One of the keywords among those 32 keywords in C. So in calloc, this is a size n and this is a size of int. Okay, so similar kind of job is there. Okay, but it will actually occupy the memory as a blocks of n number of elements, blocks of n number of elements. But in the previous case malloc, it will do n into size of int, n into size of int. Okay, and it will occupy n number of blocks, where each block has size of integer, that means 4 bytes. So if we are